Hi everyone, I'm Rahatul Amin and today I'm going to be presenting a paper on mining correlated high utility item sets using various measures. So, what do we mean by high utility item sets? High utility item sets are groups of items that yield a high profit. Suppose you bought a sketch pad and you also bought some pencil, eraser, sharpener, and a watercolor set. A group of items like this yields a high profit, and it is not rare that a group of items like this is going to be sold. So this is a high utility item set. However, a huge problem with high utility item sets are only the utility measure is used for assessing the interestingness of patterns. This means the only the profit of the of the item set is taken into consideration to identify it as a high utility item set instead of looking at the relatedness of the items inside the item set. So this leads to finding several item sets that have a high profit but contain items that are weakly correlated. Suppose you bought a television and also you bought a pencil. This type of transactions are does not happen often. This is a rare transaction. However, this is also a high utility item set because a television is expensive and whatever thing you buy with a television yields a high profit. So this item set IUI. Instead, if you buy a television and a television trolley, this is not a rare group of item and it is more likely to be sold together. So this group of item is a high utility item set. So this paper wants to find out high utility item sets which has correlated items and they're highly correlated. And let's see what else this paper finds. So what can we get from this paper? This paper proposes to integrate the concept of correlation in high utility item set mining to find profitable items that are highly correlated using the all confidence and bond measure. All confidence and bond is basically a user defined threshold. We have to calculate the all confidence or bond measure of an item set and compare that to the user defined threshold to determine if the item set is correlated high utility item set or not. They also propose an algorithm named FCHM, which is the fast correlated high utility item set miner, to find correlated high utility item sets or CHIs. They have two versions of the algorithm, which is FCHM all confidence and FCHM bond. They also show an experimental evaluation of their proposed algorithm. So let's start from the basics of how can we know the utility of an item in the item set. Suppose I is a set of items, X would be a subset of I, and D is a transaction database T1, T2, Tn. Each transaction Tc is also a subset of I, and each transaction has a unique identifier called TID. Each item I, which is in item set I, is associated with a positive number Pi. This thing is important. Pi is basically the external utility. And what is this? This represents the unit profit of this item, which means the unit profit of I. Each transaction TC has a positive number QITC. This is also important. This is the internal utility of I. This represents the purchase quantity of item I in transaction TC. So the utility of an item I in transaction TC would be the multiplication of external utility and the internal utility. So utility of I in TC would be Pi multiplied by QITC. Suppose we have a table like this. It shows the transactions, and this is another table. It shows the profit of each item. So from this table, we can find the utility of A in transaction 1. So in T transaction 1, to find the utility of A, we need to find the external utility and the internal utility of A. So the internal utility is 1, the external utility is 5. So when we multiply 5 into 1, we get 5. So the utility of A in transaction 1 is 5. Similarly, the utility of AC can in T1 can be found like this. Like we already have the internal external of A, we need to find the internal of C1 and external of C1, internal of C and external of C, which are also 1 and 1. So if we multiply 1 and 1, we get 1, and we add it up with the utility of A, which is 5 into 1 plus 1 into 1 is 6. So the utility of AC is 6. Similarly, the set of transactions containing item set AC in DB would be transaction 1, transaction 3, transaction 4. These transactions have AC in them. So the utility of AC in DB is defined by GAC, which is T1, T3, T4, and the utility of the item sets would be UAC T1, UAC T3, and UAC T4 added, and there would be 28. So now that we can find the utility of items, how to identify high utility item sets? An item set X is high utility item if utility of X is greater or equal to the minimum utility. The min util is the user specified minimum utility threshold. Suppose the mean util is specified as 30, and you get that UAC, the utility of ACE, is 31, and the utility of PQR is 29. So we can say that utility of ACE is greater than mean util, so this is a high utility item set. The utility of PQR is less than the mean util, so this is not a high utility item set. The problem with high utility item set mining is to discover all the high utility item sets. For this, high utility item set mining algorithms utilize the transaction weighted utilization, or TWU measure, to prune the search space and narrow down the focus. They first identify candidate high utility item sets by considering their TWUs. Then they prune the low utility high utility item sets. To calculate the transaction weighted utilization TWU, we need the utility of each transaction of TU, each transaction which is defined as TU. So let's find the utility of T3. The utility of T3 would be A, C, and D's utility. So utility of A T3 plus utility C T3 plus utility T33, it would be the added utilities, and it would be 8. And similarly, we can also get the utility of T1, T2, T4, and T5. Let's find the utility. Let's find the TWU of A. So the TWU of A would be where we can find A. So the transactions where A is located is T1, T3, and T4. So TWU of A would be TU T1 plus TU T3 plus TU T4. And if we add the utilities, we will get 65. Similarly, we can also get TW of B, C, D, E, F, and G. Similarly, let's find the TW of CD. So we have to find in which transactions CD is located. So we can find that CD can be found in T1, T2, and T3. So the TWU of CD would be TU T1 plus TU T2 plus TU T3. And if you add them up, we can get 58. Now we have to prune the TWUs. Suppose X is an item set, and if the TWU of X is less than the mean util, then X and its supersets are low utility. We can prune them. Suppose the mean util for this one was 50, and we found that TWU of CD is 58, so it is greater than mean util, so we don't need to prune them, and we can accept it as a high utility item set. A drawback of algorithms working in two phases is that they generate a huge amount of candidates, and it also takes a lot of time. So we have seen that they first find the TWU, then they have to prune it to find the HUI. So there's two phases. So we need a solution for that. So what they come up with is the FHM algorithm, or the Foster High Utility Item Set Mining. The Foster High Utility Item Set algorithm works on a single phase. It associates a structure named utility list to each item set, and which lets you find the utility of an item set more quickly. We are not going to talk about what utility lists are because we don't have the time. However, FHM does not consider the correlation of items, and to find the correlation of items, the authors are relying on all confidence and bond measures. Now let's find out how to measure all confidence and bond measures. The all confidence of AD is basically the support of AD divided by the maximum support of A and D, like the maximum support between A and D. So the support of AD from this table we can find is 2, and the maximum support between A and D, we can see that in transaction T1 the maximum support of D is 3 and A is 1, so the max is here 3. So we get 3 from here, and we get the all confidence of AD, which is 0.67. The bond of item set AD is bond AD is equal to support AD divided by the D sub of AD. What is D sub? D sub is basically the disjunctive support of AD. The disjunctive support of AD is the number of transactions containing at least one item from A and D. So let's find out which transactions of A. T1 has A, T3 has A, T4 has A, and which transactions have D. T1 has D, T2 has D, and T3 has D. So the disjunctive support of AD would be T1, T2, T3, and T4, because in each transaction at least A or D is included. So the disjunctive support is 4, and from this we can get the bond of AD is 2 by 4 is equal to 0.5. Now we can find the correlated high utility item sets, or the CHIs. An item set is CHI if it is an high utility item set and its bond or all confidence is no less than a user defined threshold. Suppose user defined mean util is 30 and user defined mean bond is 0.6. From the DB, we found that the item set BE is a high utility item set with utility greater than 30, which is more than the mean util, and its bond is 0.75, which is also more than mean bond. So we can say that BE item set is a CHI, or a correlated high utility item set. The authors also suggested some strategies for the all confidence and bond measure to improve the FCHM algorithm in this paper, but we are not focusing on those. Let's see the experimental evaluation now. They had 4 real-life datasets commonly used in the high-utility item set measure literature, and these are mushroom, retail, Cursor, and foodmark. Here in the table they're showing these are the distinct items, these are the number of transactions, and these are the average transaction length. I'm not sure what they use this one for, but they're using this with their algorithm D and I, and they show that the orange line here is their previous algorithm, which is FHM, and the others are their newer algorithm, which is the FCHM. And this is the count of high utility item sets, and you can see that their previous algorithm finds more high utility item sets than their newer one. So in every data set we can see that the new algorithm is performing way better than the previous one, and the new algorithm is finding less high utility item sets, and these item sets are with items that are correlated to each other. And the authors are saying that these so the item sets that are being found by FCHM are actually CHIs, the correlated high utility item sets. They also show that FCHM is faster than FHM, and FCHM also consumes less memory to run. Their future plan is to design more efficient algorithms in terms of runtime and memory consumption. They also talked about designing an alternative method or structure for computing the disjunctive support would be beneficial because it takes takes lots of memory. So designing an alternative would be better. And they also plan to integrate the concept of correlation to mine other types of patterns such as correlated sequential rules. Thank you so much. I would like to answer your questions.